Welcome back to our video tutorials. Today we are focusing on the 10th component of the pneumatic motor, the crankshaft. In this video, we are constructing the crankshaft with the focus on the characteristic cutouts of this component. We will create these cutouts in two different ways. First, using the offset plane feature, and then through extrusions with offset. Along the way, we will also learn how to project geometries to enable precise and efficient constructions. Let's get started right away and design the crankshaft step by step. We start, as is common with rotationally symmetrical components, with a sketch on the YZ plane. First, we create the center line, which serves as the axis of rotation. Afterwards, we draw the contour that will be used for the rotation later. It is important to create only the contour to be rotated. We will deal with the cutouts at a later stage. Alternatively, it can be helpful to load an image of the drawing directly into the program, similar to the crank pin. This way, we can trace the contour more easily and precisely. Once the contour is completely created and dimensioned, we close the sketch. In the next step, we perform the rotation to generate the basic shape of the crankshaft. Now we create the first cutout using an offset plane. Go to the toolbar, select the construction area, and choose the offset plane command. As a reference plane, you can select either the XZ plane or directly the front face of the part. Then enter a measurement of 8.8 millimeters. Check whether the new offset plane is shifted in the desired direction. If the plane is pointing in the wrong direction, you can simply put a minus in front of the value. After the offset plane has been correctly positioned, we begin with the sketch for the cutout. To maintain a better overview, activate the option slice in the sketch palette. Currently, we cannot anchor a line to the circular contour. To work with the contour, we must first project it onto our sketch. To do this, we select under Create, Project, and Include the Command Project. Mark the outer contour of the crankshaft to transfer this geometry directly into the sketch. Make sure that the projection link is activated in the sketch palette. This way, future changes to the part geometry will automatically be transferred to the projected lines in the sketch. Next, draw a horizontal line on the projected geometry. You place this at a distance of 2.5 millimeters from the origin. This way, the position of the recess is precisely defined. Finish the sketch and select the desired area for material removal in the extrusion command. It's good to know here that the projected geometry is sufficient to close the contour. Finally, set the length to 12 millimeters and we have completed the first milling. Now we create the second milling cut, this time in a slightly different way. Instead of using the same approach as before, we start with a new sketch on the front of the shaft. In this sketch, we draw the contour that is to be removed. Make sure here as well that the contour is cleanly drawn and fully dimensioned. After the sketch is finished, we select the contour in the extrusion function. Similar to the first cutout, the contour is automatically closed by the circular arc. In the settings, we change the start option to offset and enter a value of -10 millimeters to shift the extrusion by that distance. Additionally, we set the direction to symmetric and the measurement to total length. For the distance, we enter 4 millimeters, which gives the recess the desired length. Confirm the input, and the second recess in the crankshaft is successfully implemented. With this alternative method, we have learned another way to create recesses. Finally, we add the 2 holes and the chamfers as usual. For the drilling on the milling out, we can simply choose the center point of the surface as a reference and create the drilling up to the XY plane. This time, the angle of the phases is not 45 degrees, so we need to change the type of phase to set the angle to 20 degrees. If the angle points to the wrong side, you can simply click on reverse. Finally, we change the material to bronze to complete the crankshaft. Don't forget to save your component. As always, we take a brief look back at what we learned today. We got to know various methods for creating cutouts and applied the functions of offsetting planes, projecting, and extrusion with offset. In the next video, we will focus on the last component of our series. This time, a sheet metal part awaits us requiring other exciting functions and methods. Stay tuned and good luck with trying it out.